Welcome to the Astro Guy podcast. I'm your host, Wayne Zool. Hopefully, you've had a chance to enjoy some cool October evenings of observing the night sky. In New Jersey, September started off great with 11 clear nights in the first 15 days of the month. Statistically, however, October is the month with the most clear nights, at least in this part of the country. I was fortunate to do a bunch of wide field imaging during those clear nights, and I'm hoping that the second half of October is just as good. You'll see why in a minute. In early August, we did an episode entitled All About Comets. If you want more information on what comets are, you may find that to be a fun resource. We also mentioned this particular comet in our What's Up in the October 2024 Skies episode. I'll leave a link to both episodes in the show notes. By now, however, you must have heard something about Comet Tsuchinshan-ATLAS. Well, let's dive into it. To review, comets are made up of several parts. The nucleus is the solid central part of a comet. It is comprised mostly of water ice, with frozen gases and dust, as well as many organic compounds. Comet nuclei can be as small as tens of meters across, to as large as around a couple of 100 kilometers in diameter, although comets with very large nuclei are extremely rare. As a comet nears the Sun, heat causes the comet's ice and other substances in the nucleus to vaporize as they form a cloud of dust and gas around the nucleus. This cloud is called the coma. The coma can grow to thousands of kilometers in diameter, and the light reflecting off of the coma makes it visible to us. Comets, however, are known for their tails. Comets can have two different kinds of tails, a gas or ion tail and a dust tail. The gas tail is made up of charged particles, known as ions, and it will always point away from the Sun due to the solar wind. The ion tail tends to be fainter and is usually best seen in a telescope or with long exposure images. However, with some bright comets, the gas tail can be seen with the naked eye. A comet's dust tail is made up of solid particles and is usually curved as it follows the comet's orbit. The dust tail is what we are usually able to see when there's a bright comet. In our solar system, comets originate from the Kuiper Belt and the Oort cloud. Comets originating from the Kuiper Belt are what we call short-period comets. They have orbital periods of 200 years or less. The Kuiper Belt is a donut-shaped shell that stretches between 30 and 55 astronomical units, or AUs, from the Sun. The comets here were thought to have formed in the very early stages of our solar system. The Oort cloud, however, is a vast, spherical shell of icy bodies that surrounds the solar system. It occupies an area about 2,000 to 100,000 AUs from the Sun. This is where long-period comets come from. Comets here take thousands or even millions of years to complete one orbit around the Sun. The comets in the Oort cloud were scattered by the gravitational impact of the gas giant planets during the formation of the solar system. Occasionally, gravitational nudges from passing stars or the galactic tide can disturb comets in the Oort cloud, sending them on their long journey to the inner solar system. Soon to grace the evening skies is Comet C2023-A3 Tsuchinshan-ATLAS. This comet originates from the Oort cloud and may be on its first visit to the inner solar system. Astronomers are predicting that the comet may possibly be ejected from the solar system after it reaches perihelion, so this may be its only visit to the Sun. It was first observed by the Purple Mountain Observatory in China on January 9, 2023. It was independently identified by ATLAS, which is an acronym for the Asteroid Terrestrial Impact Last Alert System, on February 22, 2023. ATLAS is a half-meter f2 Schmidt camera located at the Sutherland Observatory in South Africa. When the comet was discovered, it was about 7.3 AUs from the Sun, or just over 1 billion kilometers, or 680 million miles away. It was magnitude 18.7 at discovery. In January of 2024, the comet had brightened to magnitude 13.6, and by the beginning of May, it was at magnitude 10. This is when I first imaged the comet with my C8. At the time, the comet was around magnitude 10.1, and was sporting a tail about 5 arc minutes long. In early May, a Czech-American astronomer suggested that the comet may disintegrate before even reaching perihelion. Thankfully for us, that's turned out not to be the case. The comet was lost in the glare of the sun from mid-July until it was observed again on September 11th. However, the stereo probe, which observes the sun, was able to spot it in mid-August and noted that it had brightened to magnitude 7. When the comet emerged in the morning sky in mid-September, it was continuing to brighten, and its tail had grown to more than 10 degrees long, but it was low in the eastern skies before sunrise, making it challenging to observe an image, even though it had brightened significantly. On September 27th, the comet reached its closest approach to the sun, at a distance of 0.39 AUs. A few days later, it again became lost in the glare of the sun, where it will remain until it reemerges in the evening skies on October 12th. It just so happens that on October 12th, the comet will make its closest approach to us at 0.41 AUs, or a distance of 71 million kilometers, roughly 44 million miles from Earth. The comet will be at its predicted brightness on October 9th, when it will be at magnitude minus 4.6. Unfortunately, it will appear a little over 3 degrees from the sun, making it nearly impossible to see. When the comet makes its reappearance in the evening sky, it will be at magnitude minus 1.6, which should make this an easy naked-eye comet. It's expected to be so bright due to a phenomenon called forward scattering. This occurs when a comet is backlit by the sun. It can look much brighter than it actually is. The dust and ice crystals in the comet's coma and tail scatter light directly towards us, making it appear more luminous to the observer. Essentially, its light is being reflected in a way that enhances the comet's overall brightness, giving us a more dramatic view. From the 12th on, the comet will appear a little higher in the sky each evening for the rest of the year. As it continues to move away and dim, it gets lost from our view completely. It moves through Virgo, then into Serpens Caput, Ophiuchus, Serpens Cauda, and then into Aquila. On October 12th at 7 p.m., the comet will be about 8 degrees above the western horizon in Virgo. By the 15th at 7 p.m., the comet will be 18 degrees above the western horizon in Serpens Caput. This should give you plenty of time to observe it as it skirts past the globular cluster M5. The comet will appear just over 1 degree away from M5. I'm sure that we'll see some beautiful images of this. On October 21st at 7 p.m., the comet will be 31 degrees above the horizon and will appear a little over 4 degrees from the globular cluster M12 in Ophiuchus. The comet is predicted to be at magnitude 3.6 and fading, and again, the wide-field imagers should be able to create some amazing images of this pairing. On October 28th, the dimming comet will glide past the 4th magnitude Summer Beehive cluster, IC 4665. The pair will be separated by about 2 degrees, and at 7 p.m. will be 36 degrees above the horizon. As you can tell by these last few examples, the best times to see the comet will be between sunset when it gets dark and when the comet sets, so you want to make sure that you have a good western horizon to observe the comet. Now you know when to look, but how can you see it? In our All About Comets episode, we devoted a chunk of time on how to observe comets. Again, there's a link to it in the show notes, but let's go over the basics. If the comet lives up to the predictions, there will be several days to even a couple of weeks, depending on your sky conditions, where it will be visible to the naked eye. As I write this, the tail has been observed to be between 5 and 15 degrees long. It will be fun to see just how long the comet will be visible to the naked eye, and how long the tail will appear as the comet comes nearest to us. To help you find the comet in twilight, you'll want a pair of binoculars to scan the sky for the comet. I would use 7 or 10 power binoculars, as you want a wide field of view to locate it, and see more of the coma and tail. With binoculars, you'll be able to trace the tail, and look for subtle variations of brightness, or knots of material. You should be able to see the ion tail as well using binoculars. If you have a mount for your binoculars like a parallelogram mount, that will help you to steady the view. To observe the comet in a telescope, you'll want to use your lowest power eyepiece to yield the widest field of view. This will be helpful, especially when trying to find it. My scope of choice for observing comets is my 8-inch Dob, especially for fainter comets. But with brighter ones, I want a really wide field of view, so I often use my 70mm refractor, which, with the right eyepiece, can yield a field of view more than 5 degrees wide. After locating the comet and scanning it at low power, you can boost the magnification to make closer observations of the coma and tails. You'll want to prepare and have star charts or an app on your device to help you locate the comet. Scope out your location in advance and try to observe far away from city lights. This could be worth taking a road trip to a dark sky location. Dress appropriately and bring a folding chair or a blanket to sit on. Bring the essentials that you'll need to have a pleasant experience. Taking images of a comet can be fun and rewarding, but it definitely requires practice to get good results. Here are some basics to get you started. The easiest way to image the comet will be with a DSLR and a wide field lens. Have a sturdy tripod to mount your camera on. I would recommend using a lens between 50mm and 135mm that has a low f ratio. Make sure to have an IR cut filter for the lens, as this will reduce the star bloat. Set your ISO to 400 and open the iris all the way, then back off one stop. Use a cable release or a remote when taking exposures to avoid vibrations. You can use the 500 rule to figure out how long you can expose for. Divide 500 by the focal length of your lens, and that will tell you about how many seconds you can expose before stars will appear trailed. For example, if I'm using a 135mm lens, I would divide 500 by 135, which equals 3.7. So I would go no longer than 3 seconds. With a 50mm lens, you can go up to 10 seconds, but personally, I would go no longer than 8 seconds. The best thing to do is when practicing, bracket your exposures. Start short, then take a longer exposure until you reach the max that you want to go. Once you've captured your images, you can use a program like Deep Sky Stacker or Sequitur to stack your images and make an even better final shot. Of course, the best way to image the comet would be to have your rig on a star tracker or equatorial mount so that you can expose for longer. When I image comets, I usually take exposures between 30 and 60 seconds. This depends on the setup that I'm using, of course. I've shot comets through my C8, my Teleview Pronto, and with a Samyang 135mm f2 lens, and I've been fortunate enough to get some decent results. If you're guiding, I'd recommend to guide on stars as you normally would, but you can also guide on the comet. Doing so will produce a final image of a sharp comet with trailed stars, as opposed to tracking on the stars where you'll have pinpoint star images and a blurred comet. I'll get to that in a second. I have used an Optilong L Pro as well as an L Quad enhanced filter when imaging comets. These are broadband filters that help with light pollution. If light pollution is not an issue for you, just use an IR cut filter. After you've stacked your images, especially if you captured several minutes or more of data, you may notice that the comet will appear trailed. It's okay if it does. You still captured an image of the comet. That's something to be proud of. But there are ways to address this in post-processing, where you create 2 stacks, one registered on the stars and one registered on the comet. It's not a simple task, as there are a lot of steps, but I think that based on images that others and that I have produced show that it's worth learning to do. I'll leave a link to a video by Visible Dark about how to do this in PixInsight. So whether you're just casually trying to observe the comet, or maybe you plan to drive to a dark site where you can take pictures, it will be worth the effort. This could be a once-in-a-lifetime event, and you'll want to share the experience with friends and family. This comet may never be seen again. It may be the brightest comet that you'll ever see. Let's all see what Comet Tsuchinshan-ATLAS has in store for us. I hope that you have clear skies and that you get many nights of enjoyment with this comet. Well, that's all for this episode. Thank you so much for joining us, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy podcast group on Facebook. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please do all the podcast YouTube things, such as like, subscribe, comment, and share. It really does help us. If you'd like to support the Astro Guy Podcast and YouTube channel, you can do that by buying us a cup of coffee. The money is used to maintain and update the equipment that we use to create and publish the show. The link is in the show notes. Thank you again for joining us, and may your skies be clear. As always, Carpe Noctem, seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.